Well, you can see that I'm outside today. This is Saturday morning, and I was supposed to be spending most of the week doing load development and regulation on these double rifles, and that really hasn't worked out. Pretty much all week long we've had heavy rainstorms, thunderstorms, tornadoes, and high winds. Monday through Thursday I was pretty much trapped in my shop. There was no way to get out and shoot. It was raining, overcast, heavy winds, lots of tornado warnings, thunderstorms. So I didn't get to shoot Monday through Thursday. I didn't, however, waste my time. I had a project in mind that I've wanted to do for a couple of years now, and so I sat down and did most of that work in the shop since I couldn't get out and shoot like I wanted to. I'm sitting at a brand new shooting bench here, and this is what I've wanted to do for a couple of years now. I wanted to build a brand new shooting bench with a left and right hand side and with a standing rest so that I could shoot and do the regulation work from standing like a double rifle needs to be done. So that's what I spent most of my week doing. Yesterday, it was pretty cloudy and overcast in the morning, but there wasn't any rain, and it was just some wind. So I got out and cleared my new range and got my bench and my new target set up. So I'll give you a brief overview of this. You can hear by the way the wind's kind of howling around here. I might not get any shooting done today either, and it is pretty overcast, so it looks like we might get some more rain today. So not getting a lot of shooting done this week, but I'll run you through my new rifle range, my new bench and everything, and I'll talk about how I get my loads developed for most of these big bore guns, and then I'll show you where I get that information from, and I'll run you through some I've got a video that I did on a different double rifle that talks about regulation, so I'm going to edit that clip down and add it to this video, and hopefully that'll explain regulation pretty good. But I'll give you a quick run through of my new rifle range and why I built a new range, and we'll go from there. So this is my new bench here. You can see it's got a couple upright posts in the back and a strap running across the center there for doing, nice standing rest. Good place to put your arm. And when you're regulating double rifles, you really do need a standing rest to do this. You need the gun to be able to free recoil and allow for any movement without anchoring it down any. But the rest of the bench is pretty standard. It's a right and left-handed bench. It's built out of pretty solid material. It's almost all 4x4s and then some 2x4s for the top and whatnot. You can see downrange here I've got a new target set up, and then right now it's sitting at 25 yards. There's a post farther back that I can move it to. It'll take it out to 50, and I'll walk downrange and I'll show you how I made the target. Did it a kind of particular way because I want to start recovering some lead, so I'll show you how that's built. You can see I've already started to run a few rounds through it. Friday evening, after I got all this set up, it was calm enough and kind of nice for about 2.5 to 3 hours, and I did manage to do a little bit of shooting. Really didn't have enough time to do any real load development or anything. I was mostly just testing out the new target and my new bench and just playing with the guns a little bit, but I did get a few rounds put down range with it. But I wanted to show you how I built this target. It's 4x4s and 2x4s just like the bench is, but 1-inch steel plate back here. Good heavy chunk of steel back here. It's set at 40 degrees in the angle, and this bench is wide enough. You can see down there at the back how the dirt's all kind of scuffed up. That's from where these first shots were deflecting down, so they're hitting and deflecting down to the back, which is really what I wanted to see. And this is wide enough through here that I can stick a big Rubbermaid toad in there, one of those big gray ones from like Walmart, and fill it full of sand, and it'll set right there at the back. And when I'm shooting, I'll just take the lid off of it, and those balls are going to deflect down into that sand, hopefully, and the sand will catch them. And when I'm not using it, I can put the lid on it and put a weight on top of it so the lid doesn't blow off, and it'll keep the sand from getting wet or filling the tub full of water. And this way I'll be able to recover more of my lead. Since I do a lot of big bore work, 10s, 8s, 4s, 2s, that kind of thing, 2 bores in particular, every 2 shots you make, you're putting a pound of lead downrange, and that's a lot of lead just to waste. So I'm looking for a method to hopefully start recovering a lot more of my lead these days and reusing it, and I'm hoping that by having a sand trap at the back of this, it'll catch that lead and keep it in a nice container where I can just dump it out once or twice a year and sift it through and recover all my lead from doing the range work on this stuff. So this is sitting at 25 right now, and you see that silver post back there right at the corner beside the tree. That's 50 yards right to that corner from my bench. The reason I wanted a new rifle range in general, is my old range runs from basically that tree over there down that way, and there's a 50-yard target, and then farther down there's a 100-yard target, and then clear out at the fence line there's a board out there that's at 150 yards, and it's a really good range. The problem is I can't use it all year long. Right now you can see that my pasture out there is about 2.5–3 foot tall of grass that hasn't been baled up yet, and so there's a time period here in the spring when my range is more or less inaccessible because it hasn't been baled off yet. And setting it up this way with the new range here in my field road, I keep this area clear pretty much all the time, and it is actually right back at the back corner of my shop. There's where my bench is, so it's a convenient location, and I keep this stretch of my driveway and my field road mowed down and clear year round, so I'll be able to shoot at least to 50 yards year round this way, and I won't have to change or move my setups at all. And then you know, for the few months of the year when I can't get out in my pasture to use my 100-yard range, I'll be able to at least continue to do, you know, short work anyways. So this is a good setup, and I'm hoping this target works out the way I want. You can see that there's impact strikes from last night. That 1-inch plate should handle pretty much anything I'm ever going to do, since almost everything I shoot is cast lead bullets and cast round balls. That 1-inch plate should hold up for a very long time. The board on the front of here is obviously going to take some abuse, but it's just screwed in a couple screws so I can replace it as needed. And that should make a pretty good setup, and hopefully I'll be able to recover most of my lead this way. So I'm going to go back in the shop now. I'm going to show you how I find some load workup ideas and get some early starting points for load development on most of these guns that I build, and then like I said before, I'll edit a video that I've done before on how regulation works, and I'll add that to this video this week. If the weather allows it to clear up a little bit, it's a little too windy to actually be out here trying to shoot for load development. It just wouldn't be productive, I don't think. But if it clears up, I'll try and get some video of some shooting done this week too, and show you how these double rifles shoot. So the way I start load development usually on these bore guns is in my library, and I've got a pretty substantial gun library. Actually, I've got a pretty substantial library period, about 3,000 books total, but I've got several hundred gun books, and a lot of out-of-print stuff and stuff that I've had to pull off the internet that was out of copyright and have it reprinted and bound. So I've got a pretty good library. I just grabbed a couple of them to show you how I find my load date on this stuff. This is W.W. Greener's The Gun and Its Development. Really great book. Tons and tons of really good information on double rifles and stuff in here, and fitting guns and stuff like that. So really great book to have if you can find a copy of it. But it has ballistics charts in it and original load developments from the time period. The other book I've got out here is a fairly new one I just got last year. It was just or earlier this year, and it was just published recently. This is British Boar Rifles by Cal Pappas, and Cal's done a really great job with this book. I highly recommend, you know, if you are into double rifles and bore rifles, this is a great book to have. Hundreds of pages of full color photos, but Cal did a really good job of pulling information from a bunch of different sources and reprinting load charts and data for bore guns. So really good information in here, and then like I said, tons of really great photos. So a good book to buy if you're into this kind of stuff. Anyways, these charts have you know, different authors, different hunters use different loads. You can dig through these books and find different loads for most of the bore guns from the original time period. And like the greener book here, you get down to the 10 bores here, and it's got ball diameter, powder charges, weight of the bullet, and ballistics charts that go with it for yardages and distance, and weight of the weapon and that kind of thing. So it's really good information. And what these numbers give me is on these powder weights for these 10 bores. Usually what I do is I'll dig through my books and I'll find the lowest charge that anybody was using. It doesn't matter whether it's Greener or Taylor or Celis or whoever I happen to find the load data from, but I'll dig through my books and I'll find the lowest charge, and then I usually cut it back to about 75% of that load, and that's where I start my load development from and work up from there. It's a good starting point. You take the lowest load you can find from the original charges and cut it back to about 75%, and then start developing the load up until you get the best accuracy. Sometimes I do have specific requests from customers that they want, a certain load, or they want it regulated a certain way, and so I kind of got to work around what my customers' requests are. But for the most part, I try to stick to the original loads, original powders, charges, and velocities. Reason is if it worked in the 1800s, it'll work today just as well. So lots of good load data in these books, and like I said, I've got a pretty substantial collection of books these days. Tons of these kind of charts in there, and that's where I get my starting information from. And then I develop the load for the best accuracy from each barrel, and then I try to find a common load that works with both barrels and gives me the best accuracy with a single common load. Weather's not really improving, so what I'm going to do is I'm going to edit that other video I told you about that talks about regulation. No point in me rediscussing the same information again when I've already done it for a different gun. So I'll edit that, add it to the end of this video, and it doesn't look like you're going to get to see me actually shoot this week. But hopefully the weather will be better next week, and I'll be able to get out and get some video of me actually shooting these guns. So, with the ribs on, everything else is attached, the weights are in it, the gun is basically finished. I mean, obviously there's some finished work to do, but as far as being a functional rifle that's, mechanically sound and has all of its parts attached, that rifle is finished in terms of mechanical workings. Obviously, there's quite a few hours of finish work to actually do. But since we're at this point, I like to stop and give a little discussion on regulation, because there seems to be quite a bit of misinformation and confusion about regulating a double rifle. For some reason, some people seem to think that this is some kind of black art, and that if you don't learn it from some professional builder, you'll never understand it. And that's just simply not the case. Regulating a double rifle is really not as complicated as a lot of people make it out to be. It's a fairly simple process, and there is no black art to it. It really just boils down to some fairly simple physics. So I'm going to try and explain this, and hopefully I can clear up some of the misunderstandings. But if I can't, if all I do is muddy the waters, well, at least I gave it a good try. So I've got a couple things drawn out here. I've got the muzzle view, regulation wedge, front sight, and the under rib, and that's basically how it looks. And then I've got a couple of center lines of the bore. If you were looking top down and you took the barrels away, all you would see is the bore line basically, and this would be center lines of your bore lines. So that'll give you an idea. This will help me illustrate some of this stuff. There's two basic arguments, and I've been involved in this discussion a number of times in the past 10 years, and it basically, I think it boils down to a little bit of misunderstanding. But the two basic things that are most often argued about is, do the barrels cross, making the bullets cross at a certain point of impact, or do the projectiles, the bullets, shoot parallel to infinity on a double rifle? And I think that's the biggest misunderstanding, is that both answers are sort of right. A well-regulated, properly adjusted double rifle will shoot parallel to infinity. But if you put a laser sighter in each bore and shoot a laser down the bore, it will look like the beams, the path of the laser, crosses at a certain point, and that's your generally considered point of impact. And so I think that's where the biggest misunderstanding comes from, is that yes, the barrels do converge, and so you would think that the projectile would converge at some point where the barrels are crossing. Your basic triangle idea. You know, base of a triangle, two tapering points, and that your bullets would cross. That's not actually the case, though, and it's a little matter of physics, and it's really not, you know, you say physics and people go, I don't understand that. Well, it's really not that complicated. Really what it boils down to is mass and velocity versus time and travel, or time and distance, if you want to say it that way. Time and distance, or time and travel. So, you know, you've got your muzzle, you've got your mass of your projectile and the velocity at which it's traveling down the barrel, and you've got the amount of time it takes to go from the chamber to the leaving the muzzle, and the distance that covers. So what matters is how long it takes for it to cover that distance. Once the bullet leaves the muzzle, then you have absolutely no control beyond that point. From that point on, the bullet is going to do whatever it was doing once it left the muzzle. Whichever direction it was pointed, that's where it's going to go. So, when I say that both arguments are right, that yes, the barrels do point to a single point at a certain distance, but that the projectiles fly parallel, or should, as close to parallel as you can make it, both statements are actually true, and I'm going to explain why. So, mass of the projectile, the velocity at which it's moving, versus the time it takes to get from the starting point to leaving the muzzle. And here's how it works. If both barrels were parallel, if they were truly parallel, and you can see I've drawn this with a little bit of a taper in it. If both barrels were truly parallel and everything was, you know, absolutely perfect down the center line, and your bores were parallel to each other, your projectiles would not ever regulate to a point of aim that would be usable in hunting. The reason is because when you pull the trigger, primer goes off, powder explodes, projectile starts to move down the barrel. The distance and time it takes to go from here to here comes back to the simple law of everything has an equal and opposite reaction. Once that projectile starts moving, then the recoil forces push back against the shooter. They push back through the stock and back into the shooter. The muzzle starts to rise from the recoil forces. When that happens, if your barrels are parallel, not adjusted for it, the barrel is actually moving up, and to some degree it's rotating to either the inside or the outside. And that depends on whether it's a left or right-handed gun. So I'm going to give these in kind of general terms because this is going to be a left-handed gun, but it works the same, you know, works a mirror image basically if it's a right-handed gun. So what happens is the bullet has time, and it happens in, you know, fractions of a second. It takes a fraction of a second for the bullet to go from the chamber to the end of the muzzle, but that amount of force and recoil changes your starting position, and it moves the muzzle of the rifle up, and because it's rifled and things start to turn in the rifling, the projectile starts to turn in the rifling, it also causes the gun to rotate. There's also a second reason that the gun rotates. It's actually every gun does this. Single shot rifles do this too. Bolt guns, you know, every gun does this. But you don't notice it on a single gun because the point of rotation on a single gun is the center of the bore. The point of rotation on a double rifle is the center of the barrels. And so what happens is, from the time you fire it to the time it leaves the muzzle, the recoil forces act against it, the barrel starts to rise, and the barrel also starts to rotate. And so if you're looking at this as a left-handed gun, when you pull the trigger, this thing is rotating up and to the inside, changing the location where the bullet or ball leaves the muzzle. When you shoot the other chamber, the point of rotation is here, not here, and so the muzzle starts to rise and rotate out again, because you got to keep in mind that you're shooting off the shoulder. You're not shooting from a center point, you're shooting off the shoulder, and so the barrels are going to rotate off the center point of where it anchors on your shoulder. It's not going to rotate off the center point of the barrel, it rotates off the center point of where the forces act against your body. So this is where the confusion comes in. If these two were absolutely perfect and true and parallel, these forces, the time it takes and the distance it covers, changes the position of the muzzle, and if these two barrels were parallel, then one ball would leave at a location up here and the other ball would leave at a location up here, and being that they were parallel, the balls, once they travel over distance, because the farther away you get from the point of separation, the more they're going to cross. So these things have to be adjusted for. That's why there's a regulation wedge built in. That's why sometimes you have to regulate a midpoint wedge, is to change these barrels' locations so that at the point they leave the muzzle, they're both going to end up shooting parallel over distance. And so that's really what regulation boils down to, is making the adjustments here, both bringing them together and apart and adjusting them up or down, so that when the projectile leaves here, it's going to end up shooting at a parallel line. And I know this seems kind of odd and weird, and it's just kind of confusing to a lot of people, but it really is very, very simple physics. It's the mass of the projectile and the velocity it's traveling over the time and distance it takes to leave the muzzle, and then the recoil forces that cause it to change the muzzle position. So, how do you regulate this? Well, it's really pretty simple. In a common caliber, like say a 375 H&H or a 458 or a 450-400 or any of those, any of the 470-500, any of the known calibers that there's factory ammunition for, usually you would regulate them for the factory load. You know, the weight of the projectile and the factory velocity on factory ammo, because that's what most people are going to be able to purchase and buy. Obviously a lot of guys are hand loaders, and so they can adjust their loads as they see fit. But double rifles, because you're dealing with a certain set of criteria, mass, velocity, time, and distance, you have to keep your projectile leaving the muzzle at the same point in the rotation in order for it to shoot and regulate properly. So you can change projectiles, but if you change projectiles in a double rifle, you have to change the load so that the mass and velocity versus time and distance comes out the same when it leaves the muzzle. And that doesn't mean that the velocity has to be the same leaving the muzzle. It means that in combination, the point at which the muzzle is in its rise and roll has to be the same. The place to start on doing this is to work up a load. And when I say work up a load, you know, anybody who's ever done this for accuracy understands that it's not necessarily about getting the maximum velocity. It's about getting the most accuracy. And so what I'm going to do is, I mentioned earlier that I'm going to start with a low load that I know the velocities on it, I know the accuracies on it, and I know it works in a single barrel gun. Hopefully, I will find a common load that will shoot very accurately in both barrels and not give me any problems. And that's what the goal is in working up a load, is to find a common. It's to find a common load that shoots with the same precision and accuracy out of both barrels. When you're talking about double rifles, accuracy is a little bit of a different term than it is when you're talking about most hunting rifles and most bench guns. Bench guns, you want to shoot the absolute precision, consistency over and over and over again with the smallest possible group. Hunting rifles, obviously, there's a little bit of leeway. You're not poking paper. If you've got good accuracy, generally most people consider 1 MOA to be good hunting accuracy. That's usually acceptable. In a double rifle, accuracy is defined a little differently, because these are regulated to a given distance. In the case of this rifle, the single fixed leaf is going to be regulated for 50 yards. Accuracy on most double rifles, and kind of the industry standard, is 3 inches at the regulation distance, meaning that if you shoot a left and a right, a left and a right, a left and a right out of the muzzle, you should end up with a group of lefts and a group of rights that fit inside a 3-inch diameter. And dangerous game is not typically hunted at 300 and 400 yards. It's hunted very close, 50 yards or less, and a lot of times lots less. So regulation on this is going to be set at 50 yards. But a guy can really work on it. He can really work his load development, and he can really work his regulation, adjusting the wedges, the muzzles, and whatnot. And a lot of times you can get a double rifle to shoot very, very accurately. But it should shoot. The left barrel should always be left of center, and the right barrel should always be right of center. They should not actually be crossing at any distance. They should shoot parallel. So to make those adjustments, what a guy has to do is he has to work up a common load. And when I get to a load where both individual barrels, where each individual barrel is giving me a very good group, then I'll consider that, a common load where the one load, under whatever grain of charge it is, gives me a very consistent size of group that is nearly the same out of both barrels. That's what I'm going to consider the common load. And that's what most double rifles are set up for, is for a common load that gives you the best accuracy out of both barrels. Doesn't mean that that's the best accuracy each individual barrel will give you. It just means that that's the best accuracy you can get out of both barrels shooting that charge and that weight of projectile. Once I have that common load, then what I'll do is I'll start working on regulating it. And the way to do that is to shoot a left and a right and see where they impact the target. I happen to like these targets because they have 1-inch squares, so it makes it really easy to measure and know where you're off at. But I'll shoot a left and a right, and wherever they end up, then I'll know which way to adjust the barrels. And that's going to be dependent on where they're at. And then what I'll do is I will take it in the shop, I'll put it back in the clamps, I'll heat up the muzzles, and you remember that regulation wedge I built? That allows me to twist the barrels up or down independently, and it allows me to spread them or bring them closer together. So that's kind of indicated by these arrows, that I can move these barrels independently of each other in 4 directions. And this is kind of the part where people say, well, it's black magic. Well, it is and it isn't. It's really not black magic. It's really a matter of getting the point where the projectile leaves the barrel to give you a parallel shooting line. And the idea is it's very, very difficult. It can be frustrating, and it can take a great deal of time and a lot of shooting to do this. I've had a few. I've had one in particular that took me about 120 shots to get it regulated, and that was including the load workup to get a common load. Small barrels, small calibers with thin barrel walls are actually, in my opinion, tougher to regulate than big, heavy, thick barrels like this. The big, heavy, thick barrels like this, they're a little harder to move around, but they're stiff and rigid during the length of the barrel, and so they tend to regulate a little easier. Little thin barrels, they tend to flex really easy. They tend to be a little whippy. That's kind of my own term, whippy. But they tend to be a little whippy, and so I've had more difficulty with small calibers in thin barrels than I have with bigger calibers and heavier barrels. But that's about the gist of it. And that's pretty much where I'm at. And I'll shoot for some accuracy, and I'll work my way up. Once you shoot it a little bit, it's pretty easy to figure out what's going to work. There's that certain point where increasing the powder charge starts to open the groups back up. Once that happens, you know that you're going to be in a range between a certain charge. That's how it works, and that hopefully that clears up the idea that they cross versus do they shoot parallel. I'll reiterate it one more time. If you stick a laser sighter down the bores of a double rifle and you trace the lasers out, it will appear that they cross at a given distance. But when it's actually shot, because of the dwell time, the time it takes from the bullet to get from the starting point to leaving the muzzle, and the recoil forces that act against it, a well-regulated double rifle should shoot parallel on horizon to infinity. Obviously the horizon line, as the bullet loses velocity, is going to continue to drop to the ground. But as far as, on the vertical, it'll eventually hit the ground. On the horizon, though, if you look at point of impact, it should shoot parallel all the way to infinity. So getting it to do that, well, that does take a lot of work and some regulation sometimes. Sometimes you get lucky and it only takes a few shots, but a lot of times it takes considerable amount of effort to get your load workup done and get your regulation tweaked to where it's shooting parallel. So I hope I haven't made the situation worse or confused you more. Hopefully that actually clarifies some things on how regulation actually works. And as I said, if you look at it from a bore sighter perspective, where you're looking shooting a laser line down the center line of the bore, yeah, it does look like the paths cross. But when you're actually shooting it, because of the physics involved and the recoil forces and the dwell time from chamber to leaving the muzzle, they should actually shoot parallel. So, alrighty. Next week, we'll get on with load workup and regulation.